Welcome to Translating Linear Systems. Let's get started. Remember that a system of equations is just two or more equations. Now, once we get two or more equations, we can solve them. And there are three different solutions that you can get. Here's an example of these equations graphed. If you have one equation, two equations, your solution is right here where they meet. So you have one solution at that point where they cross. If you have two equations that are parallel when you graph them, then you have no solutions because they never cross, they never meet. The third option you can have is if you graph one equation, you graph the other equation, and they're the exact same line. In this case, you would have infinitely many solutions because they cross or they meet on every point on the graph. Now we want to work on translating a word problem into a system of equations. So here's one example here. We have pictures, just like the one you're going to get in class. If we buy 3 Snickers bars and 2 cheese sticks and it cost us $4.60, then the next day we bought 2 Snickers bars and 4 cheese sticks and it cost us $3.50. How can we write that into two equations? We want to first identify our variables. So we're going to use X for the Snickers bars and Y for the cheese sticks. So we had 3 Snickers and 2 cheese sticks and it cost us $4.60. Oops. Put that in the wrong spot. Then the next day we got 2 Snickers bars and 4 cheese sticks and it cost us $3.50. So there we have one equation, two equations. So we translated a word problem and got two equations, or we got our system of equations. So let's translate this word problem into a system of equations together. Claire bought 30 plain and fancy headbands from the store. The plain ones were $9 and the fancy headbands cost $12. So if she spent $342, how many of each type did she buy? The first thing you always want to do is identify your variables. It says here, how many of each type did she buy? Well, she bought plain and fancy headbands. So we need a variable for the number of plain headbands, which I'm going to use as X, and we need a variable for the number of fancy headbands, which I'm going to use Y. Now we want to translate this first sentence. Claire bought 30 plain and fancy headbands from the store. So that means the number of plain headbands and the number of fancy headbands totaled $30. You can cross this out because we won't use that again. And you'll see that this is a quantity equation. That means the number of plain plus the number of fancy is a total number of 30. That's how you know those go together. The next sentence, the plain headbands cost $9 and the fancy headbands cost $12. So what we do is we write $9 times the number of plain plus $12 times the number of fancy headbands, and she spent a total of $342. This is a value equation. Money, money, money. $9, $12, $342. That's, how they all go together. You can also cross out this sentence because you won't use those numbers again. Now we're done translating, so we've made our system of equations, which is just two or more equations. Now you remember that I said that we can solve a system of equations. So eventually we'll get into how to find x and y from these two equations, but we're not going to do that now. All I need you to remember is how to translate a word problem into a system of equations. That's it for now. Thanks for watching and see you soon.